3D Plus designs, manufactures, and tests high-reliability microelectronic modules for space applications. Typical target applications include single-board computers, digital subsystems, and instrument interfaces. 3D Plus is a US-owned company with design and manufacturing capabilities located just outside Paris, in France. 3D Plus products are designed to meet the wide range of environmental, radiation, and processing performance requirements presented by all types of space missions, commercial to military to scientific, launch to LEO to GEO to deep space. Designing in 3D Plus modules offers added multiple benefits to the design community. 3D Plus product portfolio has been developed to provide an ecosystem supporting advanced processing and data recording systems, with a wide offering of standard and custom products or intellectual property. Procuring a 3D Plus module brings you a lot more than a module. It brings you and your program team a complete proven solution. 3D Plus products are recognized by the leaders of the space industry for their use in radiation environments. From product selection to design to manufacturing and after, our worldwide tech support teams will accompany you along your 3D Plus experience. 3D Plus modules have been flying for over a decade without a single in-orbit failure, all the way to outposts of the solar system. Our products and solutions are trusted and endorsed by the key space industry players. Some of the flagship missions are New Horizons, Mars Curiosity, Rosetta, OneWeb, and many more. Today, once a month at least, a mission is launched with 3D Plus content. We hope you are the next one.
Hello everyone, I'm Pierre Wang, 3D Plus High-Rel Product Manager. I and my colleague Charles Sellier, we will present the 3D Plus memory and the controller IP core around Microsemi RTG4 FPGA. So this presentation will go through quickly 3D Plus solution around RTG4, the memory controller IP core, and also the memory radiation protections, and then make the summaries. 3D Plus is worldwide leading space product provider, especially for the memory product. Our product portfolio covers almost all kinds of the memories, including the high-speed cache memory to the high-density mass memory. So today we just talk about our solution around RTG4, the DDR2 and the DDR3 memory, and also the memory controller IP core embedded in RTG4. If you look at the 3D Plus DDR2 memories, our product covered from 1 gigabit to 8 gigabit, the configuration from 8-bit to 72-bit, maximum 333 MHz, and also in different package like the SOP, the BGA, and the QFP. So all these large bus high density DDR2 memories has been packaged in the space grade package under the Europe Space Agency PAD control. Inside the DDR2 memory has been flied many years in space. We will also introduce the DDR3 memories at the end of this year. So the DDR3 memory will be standard 1.5 DDR3 memories, and also packaged in the space grade BGA package. They will available at the temperature range from -55 to 105 degree. The engineering module will be available at October of this year, and the flight module will be available at the end of this year. So to work with the DDR2 and the DDR3 memories, we developed this Radiation Intelligent Memory Controller IP core. So firstly, it is a standard DDR2 memory controller IP core to read, write, and refresh the memories. Secondly, it is also a unique radiation hardened controller IP core. It provides unique radiation protection to 3D plus DDR2 and DDR3 memories. So this IP has been validated based on ECSS QST-60-02C, the ASIC and FPGA development guideline from the ESA. And the IP core will be delivered as a multi-user license for the VHDL code. It can be configured by the designer based on the design. So my colleague Charles will give you more detail about this IP core.
Hello everyone, I'm Charles Sellier, Electronics Design Manager at 3D Plus. Pierre won't just show you an overview of our DDR2 IP core, and now I will enter the details of this IP core. The RIMC IP core is a powerful DDR2 controller solution. The connection to this IP core is done using three different interfaces. The standard user interface is a nominal access to the RIMC controller. A bypass interface is also available to allow the user to send direct memory commands. In the specific mode, no management is performed inside the RIMC. A DDR2 memory interface is provided to connect the memory array with different configurations, no matter of number of ranks or data width, for example. The user interface is AMBA compliant. User can use AHB and AXI for high bandwidth memory accesses. An APB bus is also available for the configuration of the IP core itself. The RIMC IP core is technology independent. This means that the same core can be used for several FPGA targets, like the RTG4. So a physical layer is used between the RIMC IP core and the DDR2 components. This layer is specific for an FPGA target. This layer embeds the low-level buffers and dual data rate flip-flops, as well as clock management and clock resynchronization. The physical layer is already available for several FPGA targets. The validation is still ongoing for the RTG4. The full wrapper, including the technology-independent RIMC controller and the physical layer, can be provided by 3D Plus. Now let's see what is inside this RIMC IP core. We already saw that the user interfaces are AMBA compliant. Up to 8 masters can be connected to the RIMC thanks to the internal AXI interconnect. We also have an APB bus dedicated to the configuration. The DDR2 controller itself is also embedded in the RIMC. This controller contains all the standard functions of a controller, as well as ECC management and radiation mitigation. The number of ranks is configurable to allow the use of deep DDR2 memory modules. The number of clocks, clock enable, and ODT are also configurable. The radiation mitigation embedded in the RIMC realizes continuous specific mitigation sequences to avoid the possibility of seeing SEFI. RIMC implements a scrubbing functionality. This functionality avoids the accumulation of SAU and MBU. This function reads all the memory array. When a correctable error is detected, the RIMC writes the corrected data into the memory. If a non-correctable error is detected, an internal counter is incremented, allowing the user to take the correct action. This scrubbing functionality can be switched off. After power on the DDR2 memory array, this memory array is filled with random value, so the ECC overhead is not coherent. Therefore, the DDR memory array shall be initialized before starting the scrubbing functionality. An embedded function called padding is here to do this job. DDR2 memories provided by 3D Plus can work at frequency up to 333 MHz, which is 667 megabits per second. If the FPGA core is not able to handle such frequencies, the RIMC provides the possibility to decrease the internal frequency without modifying the DDR2 memory clocks. This is done through the freq ratio generic. This generic can be set to 1, 2, or 4. When reducing this frequency, the data path becomes wider, so a number of resources increase inside the FPGA. The RIMC is compatible with several ECC codes. First one is a Hamming code. It allows mitigation for SAU with a small overhead requested. The second one is a Reed-Solomon code. This powerful code allows to mitigate for SAU, MBU, as well as SEFI. Thanks to this mitigation, the power sequence off then on the memory array is never requested when using the RIMC. The table below lists all the available configurations. All the FreeD Plus modules are compatible with the RIMC IP core. DDR component width can be 8 or 16, and the user data bus width is from 8 to 64 bits. Thanks for your attention.
Okay, Charles give you the details about our IP core, and now I will continue about the radiation protection. From this slide, you can see the difference between before and after using 3D Plus memory controller IP. The area covered by the green line shows that our solution not only provides the memories, the standard controllers, also integrated radiation mitigations. So the user with this solution no need to test the memories, no need to understand the radiation behaviors of these memories, no need to make the design of the radiation mitigation, and we provide a fully validated and qualified and demonstrated system, radiation hardened memory systems. For example, the SEFI has been guaranteed immune integrated inside of the controller, and also different ECC can be selected to mitigate a single event upset. If you look at the detail, basically all of the hard error has been guaranteed at the die hardware level, and the memory controller IP will take care of all of the soft errors. If you look at a typical 48-bit module and the memory controller IP core configurations, you can see that inside of the 48-bit, 32-bit is for the data bus and the 16-bit for the ECC. With this structure, this IP core can correct what we call single bit upset, which means 1 bit error in 1 byte, and also multi-bit upset, which means more than 1 bit errors in 1 byte, and also the raw errors, which means all 8 bits has been upset in 1 byte. All these 3 errors can be corrected by the 16-bit ACC. More than that, a patented pending technique has been integrated inside this IP core to guarantee the device SEFI immune. So, if we look at these structures, the DDR2 memories 48-bit plus our memory control IP core embedded in the RTG4. So all these we can guarantee a memory solutions TAD higher than 100 kilorad, single event latch-up immune, single event upset immune, and also single event functional interruption immune. So if you want more detail about this radiation protection, a NASRAC paper, a published paper can be requested. So to make a summary, 3D Plus solutions around the RTG4 is including our space-grade DDR2 memories packaged in different space-grade package, including the QFP and the BGA package, and also a unique radiation intelligent memory control IP core can be embedded in the RTG4. These ready-to-use solutions will really reduce the designer's development cycle and also enhance the system performance, and protect the memories against space in radiation environment. Thanks for your attention. If any questions, feel free to contact us.